All right, in this lesson, we're going to take a look at circles, and more specifically, we're going to take a look at the equations of circles. So by the end of this lesson, you should be able to determine the coordinates of the center and the radius of a circle if you're given its equation. Write the equation of a circle if you know the coordinates of the center and you know the radius, or if you know a point on the edge of the circle. And use the equation to determine if a point lies inside, outside, or on a circle. So when we're talking about circles, the mathematical definition of a circle is that a circle is made up of all of the points that are the same distance away from a single point that we call the center of the circle. And we call this distance from the center out to any of these other points the radius. So if I pick any point on the outside of our circle, I know that it is this distance r, or the radius, away from the center of the circle. And for any of these things here, this will be r. Okay, so we can use this information to figure out what the equation of a circle is going to be. Now, before we do that, we'll just remind ourselves here what it means when a particular point lies on, well, we're going to talk about it in terms of lying on a circle, but what if a point lies on a parabola or a line? And if a point is on, like the point 2, 3 is on our parabola, what it means is that point has to satisfy the equation. Or when you take these x and y coordinates of this point and we sub them into the equation, it should make the equation true. So for instance, if I take my point 2, 3 and the equation of my parabola here, y equals x minus 3 squared plus 2, and I do a left side, right side check here, y x minus 3 squared plus 2, and I sub in my values for x and y. My y is just going to be 3. My x, I got to sub in a 2, so that'll be 2 minus 3 squared plus 2. 2 minus 3 is negative 1. Negative 1 squared is just 1. So left side equals right side. The point 2, 3 satisfies the equation of the parabola. And the same is going to be true for any point that is on the edge of our circle. So I've got this point 3, 4, which is on my circle. That point is going to have to satisfy the equation of the circle. And if I just pick some random point here, we'll just call this point x, y, I know that it has to satisfy the equation of the circle. I also know that that point has to be a distance r from the center of my circle. My center here is at 0, 0. So what I'm going to do is I'm going to figure out the length of this line segment here from 0, 0 to xy. And I know that has a length of r, but I'm going to use the length formula that we've been working with. So x2 minus x1 squared plus y2 minus y1 squared. I know that, let's just call the center here, we'll call this x1, y1. We'll call this x2, y2. And I know that my length is going to be equal to r. So r is going to be x minus 0 squared plus y minus 0 squared, just subbing in the numbers for x1, x2, y1, and y2. And this simplifies. X minus 0 is just going to be x. Y minus 0 is just going to be y squared. So we get r is equal to the square root of x squared plus y squared. I can square both sides to get r squared equals, I don't need the square root anymore because I squared both sides, x squared plus y squared. That's going to be the equation of my circle. X squared plus y squared equals r squared. So for this particular equation that we have right here, we know that our radius here is equal to 5. So this equation has to be x squared plus y squared equals 5 squared, or x squared plus y squared equals 25. And we can kind of check that this works by the fact that this equation must be satisfied by all of the points that are on the circle. So if I pick a point like this point 3,4 that we talked about earlier, we can check and see that that point satisfies the equation of the circle. So if the point we're choosing is 3,4, let's see, our left side is going to be x squared plus y squared, and our right side is 25. Subbing in our value for x, 3 squared, subbing in our value for y, 4, we get 9 plus 16 is 25. So that point that is on our circle, 3, 4, does indeed satisfy this equation. So this is our first sort of big point here, that the equation of a circle with center 0, 0 and radius r is x squared plus y squared equals r squared. Now, what if the center is not at 0, 0? We can do the same kind of thing. I'm going to say that my center is right here. I don't know what this is, so I'm just going to make up some coordinates. We're going to call these h and k. So this point right here is hk. And again, I can pick some random point on the edge of my circle. We'll call this point xy. I know this distance from here to here must be r, so that's the length of the segment joining xy and hk. So we can use our length formula again. And we can sub in what we know. We know that this is going to be x1, y1, x2, y2. That has to be a 2. And we know that our length has to be r. So x2 is going to be h minus x squared plus y2 is k minus y all squared. And we can square both sides. And the order in here doesn't really matter. So we can switch these around. X minus h squared, y minus k squared, and that's our equation. Okay. Similar to the one that we had before. So the equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. All right, what do you need to be able to do? Well, first off, you need to be able to find the equation of a circle given some information about it. So let's take a look at a couple of questions here. The circle with radius 12 and center 0, 0. Well, if we know that the center is 0, 0, we know that our equation is going to have the form x squared plus y squared equals r squared. They tell us in this question that r is equal to 12. So let's sub that in. X squared plus y squared equals 12 squared. And then evaluating the 12 squared, 144. There's our equation with that number for the radius filled in. Okay. In B over here, they don't give us, they just give us a graph or a diagram of the circle here. But just looking at this, we know that the key things that we need here are the center and the radius. Our center is at 0, 0, and our radius is, well, distance from here to here is going to be 4. If our center is at 0, 0, we know the general form of our equation is x squared plus y squared equals r squared. Let's just sub in our value for r. Well, we know that r squared is going to be 16. So our equation is going to be x squared plus y squared equals 16. A little bit trickier. The center circled at the origin that passes through the point 5, negative 3. Okay, well, if our circle is at the origin, we know, the origin, of course, is just 0, 0. So our equation is going to have the general form, x squared plus y squared equals r squared. When they give us this point, they're giving us values of x and y that must satisfy the equation. So let's take these and sub them into the equation. Our x value is 5. Our y value is negative 3. That has to equal r squared. Simplifying, 5 squared is 25. Negative 3 squared is 9. We get that 34 is equal to r squared. So right away, we can take this here, put it back into the general form of the equation, and get our equation for the circle. Equals 34. And if they would asked us what the radius is, we would know that our radius is the square root of 34. And we can just punch that into our calculator and figure out what that is if we need to. All right, let's look at D here. The circle centered at the point 3, 4 that passes through the point 7, 9. Okay, well, we can proceed kind of the same way. If it's centered at some point other than the origin, we know that our equation is going to have the form x minus h squared plus y minus k squared equals r squared. And the coordinates of this point that they give us for the center are h and k. So let's sub in h and k first. We'll have x minus 3 squared plus y minus 4 squared equals r squared. Now we just need to figure out what r squared is, and then we have our equation. Well, the point 7, 9, x and y have to satisfy the equation. So we can sub in the point x and y. So our x value is 7, our y value is 9, and we can figure out what r squared is going to be. Simplifying, that's going to be 4 squared, that's going to be 5 squared, is r squared, and again, 16 plus 25 is r squared. Looks like r squared is going to be 41. So our equation, coming back to this step here, is going to be x minus 3 squared, y minus 4 squared equals 41. And of course, if they asked us what the radius was, the radius would be the square root of 41. All right, our final question here. Does the point negative 2, 7 lie inside, outside, or on the circle from part D? Well, we've got the equation of the circle to work with here. We know our equation is x minus 3 squared plus y minus 4 squared equals 41. So we have this circle here with our center 3, 4, and they're giving us this point negative 2, 7. And we have to figure out, is negative 2, 7 here inside the circle? Is it here outside the circle? Or is it right on the circle? We could check to see if it's right on the circle by subbing negative 2, 7, so our x and our y value, into the equation to figure out if the left side is equal to the right side. But we can do a little bit more than that. What we can do is we can find the distance from negative 2, 7 to the center, 3, 4. If that distance is equal to the radius, then we know it's on the circle. If that distance is less than the radius, we know that it has to be inside the circle. If this distance is greater than the radius, we know that it has to be outside the circle. That radius is root 41. So let's work out what that distance is going to be. Well, that distance, or the length of the line segment joining those 2 points, is going to be the square root of, and let's just sub this stuff in here. Our x is going to be negative 2. Let's do negative 2 minus 3 squared plus 7 minus 4 squared. Negative 2 minus negative 3 is going to be negative 5 squared. That's going to be 3 squared. This is going to be the square root of 25 plus 9, so the square root of 34. Now, sometimes it's easier to compare these distances if we actually convert them into decimals. So let's take that root 34 and actually take the square root. That's going to give us 5.83. And our radius of root 41 is approximately equal to 6.4. So this distance here is 6.4. The distance from the center out to our point, to 7, is only 5.8. So our point must lie inside the circle. Negative 2, 7 lies inside the circle.